Okay, let's take a look at some of these animations. Over here, we're looking at the typical graph of y versus x, and over here, we're actually looking at r as a function of theta. I know it says t up here, but it's just a theta. I'm not really sure why it has that, which is kind of cool. So if you look at this spiral here, this is r equals 2t. And so you're graphing r versus t, then we know that r equals 2t just looks at some line. But on a real coordinate system, we're letting t be our angle, and as t increases, we just keep rotating around. And then r, of course, is our position vector. Okay, so let's start this animation. And as you can see, we're growing over here linearly, which is over here what a polar graph is going to do. As you rotate around, starting here, you're just going to get bigger and bigger and bigger, and it's going to keep spiraling as this keeps growing. And it's actually growing at a linear rate, right? dr, d theta would be 2, which is to say the slope over here is 2. Okay, and we kind of get that relationship, and we just get this spiral that keeps going. Okay, so let's stop this, clear everything, set this back to 0, and then let's put in some different curve. Okay, what if it was 2 plus cosine of t? How about that? And so now what it would look like? Well, here's 2 plus cosine in a normal Cartesian way, right? And then what's it going to be over here? Well, look, this is our r value, right? The y value over here is our r value over here. And as we move this way on this axis, that's us rotating over here. And so when we're here, we're at 0. That's straight away to the right. We're going to be at like 3. And then when we get straight up, we're not going to be as much. We're going to be at 2. And then when we're pointed left, we're going to be only at 1, because cosine is going to kind of oscillate. It's going to give us a lot. It's not going to give us any. We're just at 2, and then it's going to take away because cosine of pi is -1. So we start this animation, and our r value is a function of the angle in which we rotate. Hopefully you can kind of see how all this is going to work. So it's going to be fairly symmetrical. There's this little bend in over here. And then now we're over here. We're going to get bigger and bigger r values because cosine is going to be more positive there. And then boom, we're right back. Then we're just going to keep cycling through. And we can change these values and make them bigger or smaller. This looks like some cardioid, which is kind of bend in. It kind of looks like your heart. Let's clear this. And let's make this 3. And we'll make that a 2.5. So it almost is enough. Let's clear this trace. Let's start at 0 and clear it again. Start the animation again. You can play with this as much as you want. And so if you watch this guy, we're far away, and we're going to get really close because cosine almost is going to totally take control. We're going to bend in, almost get to 0, but we don't, right? Because the 2.5 cosine theta is never going to be bigger than 3. And then we're over here, we're going to get bigger and bigger and bigger and bigger, and then eventually we're right back where our cosine is almost completely adding in, and then we get this cardioid shape. Okay? All these are kind of our easier shapes because if you look at this, r is never negative. When r is negative, everything gets kind of messed up. And it's kind of, see how this is centered with the x-axis? Well, if we made this a sine curve, well then we would start clear. We kind of more of a vertical sense. So we started out at 3, and now when sine is actually going to grow. See how we're farther away now because we're going to be adding when we're straight up. And then we're actually going to be subtracting when we're straight down because that's when sine is going to be negative, right, in this 3rd and 4th quadrant. And so see how the 3rd and 4th quadrant now are the small r values, and so that's where this bending in happened. And in the 1st and 2nd quadrant, when sine is big, this is when the r values got bigger. Again, we started at 3. And what happens to sine? Well, sine gets bigger as we start to rotate. So we get bigger, 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 bigger. Sine's still big in the 2nd quadrant because it's positive. So we're taking 3 plus like a 2.5 sine. But then down here in the 3rd and 4th quadrant, now we're subtracting. It's much different than the cosine. Right? The cosine was negative in the 2nd and 3rd quadrant, which is why that little bend over here was in the 2nd and 3rd quadrant, and we were big in the 1st and 4th quadrant because r is going to be a function of theta. So there's all sorts of things we can do here. Let's just make that a 2 And we'll mess this up and make this, actually we'll just make that 2 and we'll make that a 3. All right, now we're gonna get some crazier stuff. Clear, let's go back to 0. Okay, see how much faster we rotate now? And so now, look what happens. Our R value is 0 at pi over 2. So this thing's gonna go, and it's gonna go back to 0. Start animation. So we're scrolling, going, and then bam. Right here, our R value at pi over 2 is gonna go back to 0. So look what happens here. We grow with our sine curve, but then we decay with our sine curve and we get to pi over 2, our R value is going to go to 0. Well now, look from here. From pi over 2 to pi, our R value is going to be negative. And so even though we should be rotating in the second quadrant, our R value is going to be negative, it's going to flip and we're going to all be in the fourth quadrant here. Okay? And we're back and we're back and we're back, and then boom, at pi, we're back to 0. And now, as you can see, we're from pi to 3 pi over 2, which is in the third quadrant, and our R value is positive. So as we graph this, we're in the third quadrant where we should be. Good, 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 good. And then stop again. And then once we get past 3 pi over 2, our R value will be negative. So even though we should be in the fourth quadrant, meaning our angle is 3/2 pi to 2 pi, our R value will be negative. And so instead of being in this quadrant, we're going to get flipped into the second quadrant because that's what a negative R value does. And you're flipped. So again, a negative R value, you're going to be in the opposite, and then boom, back to 2 pi, and then we just cycle through this thing again. And we can do this as many times as we want in terms of what happens to the R value when things are like that. And again, you can play with this as many different things as you want. So let's get rid of that and just make this a 1 plus. Okay, so let's look at this. And again, look what happens. We're going to have a negative R value in here. Clear, set this back to 0. Okay, so 1 plus 3 sine. Now what happens? So from 0 to pi over 2, you can see that our R value is positive. So when we start this animation, we're going to be rotating through the first quadrant, and boom, we're at an angle of pi over 2, and this whole time our R value has been positive. So look what happens. 1 plus 3 sine theta. So as theta grows, so does sine, so does our R value, so we're getting further and further and further and further away. Just like here, we're getting higher and higher on this graph. But now as I rotate through the second quadrant, my R value is still positive. I'm just going to get closer and closer to the origin because my R value is getting smaller and smaller. See how my R value is getting smaller here? And I'm getting closer. And then here, okay, now I'm going to go into the third quadrant, pi to 3/2 pi. R is still positive. So I'm in the third quadrant just for a little bit, and then, what's going to happen? Well, now I should be in the third quadrant, right? See this angle right here? I should be in the third quadrant, but my R is going to be negative, so I'm actually going to flip back to the first quadrant. First quadrant, flip, stop. Now I'm straight down. I'm at 3/2 pi, which is straight down, but I'm not straight down. Where am I? Well, I'm up. Why? Because my R value is -2. If you're at 3/2 pi, R value of -2, you're actually up at pi over 2, 2 away. Again, that's what that means. You have to think about what a negative R value does. And now I should be in the fourth quadrant, meaning as I rotate through the fourth quadrant, I should be down here. My R value is going to be negative. So I'm actually in the second quadrant. And then I finally, boom, now my R value is going to be positive for this last little bit in the fourth quadrant, and I'm going to connect this. And then I start all over again. I'm back to 2 pi, and then I'm back to that same cycle. So there's all sorts of things you can do in terms of when you do this. What if I change that to a 2? Clear. Clear, and I do this again. See, now I'm only going to be a negative R value just for this little bit. So start the animation. I'm rotating my angle through the first quadrant. R is positive. R is getting bigger. Now R is getting smaller, smaller, smaller R as I rotate. I'm in the third quadrant, and I'm going to have this really small kind of loop. Again, this whole negative time I'm being flipped. I'm being flipped into the second quadrant, first quadrant, into the second quadrant, and now I'm back. And I get a smaller loop. And it's that same thing. This loop here corresponds to this region right here. I looped back on myself because when I have a negative R value, I flip into the other quadrant. Okay, so there's all sorts of things you can do. And if you don't want to be negative, we'll just make this 1 bigger than this 2, and then of course you'll never be negative. You can play with as many rose petals as you want. Again, you can make this in there, you can make it like a 4 or something. And look how fast you're then going to go up and down. So you're going yum, 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 yum. So you're going to flip on yourself a whole bunch of time, creating all of these out, and then you're back. And then you should be in the first quadrant, but you're not, and you're going to keep flipping, and you're going to do all sorts of these loops as you keep going around. And graphing these by hand are very difficult, especially this 4T, because you're going to end up with 8 little petals, and you're going to rotate a whole bunch of times, and now we're back to 2 pi. Right, we got back to 2 pi right here, and then we're just going to do this thing over again. I can make this bigger. Hopefully you can see that this 2 here determines kind of the size, and then the 4 determines the frequency of the trig function, which relates to the number of petals. The symmetry here, since it's a sign, the symmetry is over. Actually, this one happens to be symmetric in both. But if I made this a 3, you could see it's only symmetrical over 1 axis. Okay, so instead of 8 petals, I'm going to have 6 petals. You can see it has y-axis symmetry. Oh, in this case, sorry, not 6 petals, but only 3 petals. Okay? And again, you're just going to have to play with some of these. Most of the time on the AP test, they're not going to do anything, that you couldn't be able to graph by hand. They're going to use a lot of symmetry to do things. But in the end, you can always do a theta and R chart, and it gives you a good idea of where things are at. You can play around with your graphing calculator, right? Put your graphing calculator into polar mode. So let's see if we can get to that without messing up the camera. So if we pull up our graphing calculator, all right, and go into mode, then go down to polar. Go into y equals, well then it's going to be r equals instead, and we can graph as many of these things as we want in polar mode, right? So we can get a circle, we can change that, and like I said, we can make, when you hit this, it's just going to be some sort of spheroid, so that's theta plus 1, and then graph it. It's going to be some spiral. My window's all jacked up. Actually, let's just go zoom standard. So there's our spiral. Right? And then what can we do with this? Right? So hit second, trace. Sorry, I can't really see that much. And you can find values. You can find dy dx, which is the slope, and you can find dr d theta. So let's say we wanted to find dr d theta at, we'd have to give it some input. So let's say at pi over 4. Okay, and we enter. It's going to find us dr d theta is equal to 1 at that value, which in this silly case, dr d theta is always equal to 1. We can hit trace. We can hit any angle we want. So we can hit pi over 6. And it's going to tell us the x value and the y value at pi over 6. So it's just telling us that coordinate point. And then what was the other point? So it can find x and y values at any theta. It can find the slope, and then it can find dr d theta, again, which is not the slope. Dr d theta is the rate at which r is changing with respect to theta. It's telling you whether the curve is getting further away or closer to the origin. Other than that, it can't find intersection curves. Remember, if you want to find an intersection, you're going to have to change it back to Cartesian, and then in Cartesian you can solve that equation. But in polar, you can only really do these three things in terms of that. Okay, so feel free to use your graphing calculator and play around with it a little bit and get an idea of what polar curves look like.